In my first lecture, I have compiled all the basic concepts which are necessary to give the name to the particular compound, right? So if you have followed my earlier lecture, then what you can do, you can straightforward skip 34 minutes of this particular video, because in the first 34 minutes I have again explained or compiled all the basics things which are necessary to understand the IUPAC nomenclature. Hello friends, welcome back to the tetrahedron chemistry classes. So guys, in today onwards I am going to discuss a lecture series on the IUPAC nomenclature, and the full form of the IUPAC is the International Union of Pure and Applied Chemistry. There are various roles actually which this IUPAC actually fulfills, and this IUPAC basically it is registered in Switzerland, and its administrative office, which is also known as the IUPAC Secretariat, is actually in the Carolina, United States. And there are various functions of this IUPAC. See, in simple words, what we can say, this IUPAC is the world authority, and this authority generally do the chemical nomenclature, and which includes the terminology used in the periodic table and the various standardized methods for the measurements of the atomic weights and many other things. That means the large number of things actually has been done by this IUPAC, and in the near future, whatever the new things will come, first of all it will go to the IUPAC, especially when it comes to the nomenclature, right? So without wasting too much of time in this theoretical part of what actually is the IUPAC and where is its office, I am quickly going to explain the today's topic, which is very much important for the beginners, especially if you are in class 11 and you have recently cleared your 10th result, and you are going to learn the chemistry in the class 11. So this lecture is very, very important for the 11th students, right? So first of all, you can see here what I have done. I have given you this particular example, and please note that if you find little difficulty or any kind of the difficulty in understanding the things, then don't worry, and believe me, after the completion of this lecture series, you will be able to solve any kind of the question based on the, your IUPAC nomenclature. You will not have any problem in giving the name to the structures or converting the structures to the name. You will learn all these things. But if you find little difficult, it's perfectly all right, perfectly normal, because there are various rules, and when you do the practice, only then you will be able to solve the problems based on this. So here I have given you the examples, and why I have given you this particular example, because it involves the various terms, right? First of all, you can see here I have numbered the carbon atoms present in the molecules, and the number of the carbons are 5. So please remember, whatever the number of the carbon atoms are present in the main or the principal chain of the organic compound, it is known as the word root. So this 5 carbons are there, and this 5 is the word root for this particular molecule, right? So here you can see what is word root: number of carbon atoms present in the main chain. Later I will come to this point also, actually what is the main chain or the principal chain. So if you have only one carbon in your main chain, then for one carbon, according to the IUPAC nomenclature, you will write meth. That means METH, meth is used to write carbon 1, right? And if your compound is having 2 carbons, then you will use eth. For 3 carbons, you will use prop. And if you have the 4 carbons in your compound, then you will use but. And if you have the 5 carbons, as you are having in that case, then your word root would be pent, and for 6 it would be hex, and similarly for 7 it is hept, for 8 it is oct, for 9 it is non, and for 10 it is dec. And you can go through your textbook, right, to learn beyond this C10. However, it is very, very important for each and every chemistry student to know the actually the name of these compounds which contains the from carbon 1 to carbon 10. Please, it is very, very important. So this molecule which I have shown here, it is actually having the 5 carbons. So the word root for this particular molecule is pent, because 5 carbons are there in the main chain. Okay, and after this you can see here I have written this Br here, and along with the Br I have also written the OH in that case, which is attached to this, or which is flanked, actually forming the side chains on this particular main chain, or you can say the principal chain of the compound, which contains the 5 carbons. These bromine and the hydroxyl are forming the side chain. So what are the side chains? Technically, side chain means they are the prefixes. They are generally known as the prefixes. So what I can do for you, I can write here, this is your prefix. Technically it is known as the prefix, and it is also known as the prefix. So whatever you will have in your compound, in your main chain, apart from your principal functional group, all will be treated as the prefixes, right? And after prefixes, you can easily see here what I have shown you. There is a presence of double bond between the carbon 2 and the carbon 3. Double bond is there, and see what type of the bonding is present between the carbon atoms, right, in the main chain. Actually it is the suffix. So here I have written the suffix, and this suffix can be of 2 types. First is the primary suffix. So what is the meaning of the primary suffix? Type of the bond present in the main chain between the carbon atoms. See, single bond will always be there in your compound, right? But apart from this single bond, your compound may have your double bond, it may have the triple bond. Since the carbon is having the valency of 4 only, so it cannot have more than 3 bond in any compound. Please remember, beginners, it is very, very important for you. Okay, so primary suffix means nature of the bond between the carbon atoms, and here your nature is the double bond which is present in the carbon 2 and carbon 3. And when you have the different kinds of the bonds, single, double and triple, then you have to give the different kinds of the name to these primary suffixes. So if you have all the carbon single bond carbons in your compound, then your primary suffix would be ane, A-N-E-ane, right? And if you have say carbon double bond carbon in your compound, right, then you will use ene for this. And if you have the carbon triple bond carbon in the main chain, then you will use ine for this. So this is your alkane, this is your alkene, and this is your alkyne. Okay, so you can remember in that case, if you find all single bonds, then it would be ane. If any 2 carbons having the double bond, then you will use ene, and if your carbons are having triple bond between them, right, then you will use ine for this. So you can see here, if the parent chain, see, main chain, principal chain, or the parent chain, later I will come to that point also, what is the parent chain, right? If the parent chain or the main chain contains 2, 3 or more double bonds, right? Say for example your compound is having the 2 double bond, then you have to use the numerical prefixes in order to explain the 2 double bonds. So what is the numerical prefix for the 2 double bonds? See, for 2 double bonds you will use di. That means if you have the double bond 2 times, then you will write diene. Similarly, if you can see here, if you have the 3 double bonds, then you will use tri, and if you have the 4 double bonds, you will use tetra, and so on, right? It is very, very important. And same is true for the alkyne as well. If you have 1 triple bond, then it's simply alkyne or ine. If you have 2 triple bonds, then diine. If you have the 3 triple bonds, then the triine. So it is very, very important. So I hope you understood well what is the word root in the organic compound and what is the primary suffix. And prefixes I already told you, right? whatever is present in the main chain, it is fine, because this is forming the principal chain. But apart from this parent chain, rest all things would be the prefixes in your compound. So this OH and Br is actually the prefix, right? So now moving to the next slide. So this is your next slide. It is again a very important one. What is the secondary suffix? What is the secondary suffix? Secondary suffix means the functional group present in the molecule. And guys, it is very important for you to know that functional group is responsible for the chemical properties of the compound. It is very important to know that, right? So how many kinds of the functional groups can be present in your compound? It is very important. See, if I go back in the previous page, right, previous slide rather, so this OH is a kind of the functional group, which is alcohol, and this is CHO. It is another kind of the functional group, which is the aldehyde, right? So either of these two, whether this CHO or OH, they may be treated as the secondary suffix. But remember, this would be decided based on the position in the priority table. For time being, I am telling you that CHO would be the main functional group in that case, and OH would be treated as the side chain or the prefixes, because it is in lower position in the periodic table than your CHO or the aldehyde. So if you are finding little bit difficult to know about the name of the functional group and their sign and their formula, then don't worry about that. After the completion of the lecture, you will be able to understand all the things, right? So secondary suffix means the functional group, and the functional groups are always responsible for the chemical properties. And this is the priority table. And please remember, for beginners, it is very important, not only for the beginners, but for every chemist. It is very important to learn this priority order strictly. If you have idea about this priority table, only then you will be able to write the correct IUPAC name of the organic compound. This is the priority order. Say for example, first group is the carboxylic acid. That means if your compound is having the various functional group, then the compound would be named as acid, because this acid is at the top position in the priority table. Say for example, your compound is having COOH, your compound is having COOR, your compound is having CHO, your compound is also having the OH. Then your COOH would be the main functional group, and this will dictate the chemical properties of your compound, right? And rest all other groups, they will be treated as the prefixes or the side chain. It is very important. And when your carboxylic acid, the formula for the carboxylic acid is the COOH, when it is present in the chain, then the secondary suffix, that means the name of the functional group, would be oic acid. The name of the compound will end with the oic acid. And if it is present as a side chain, then it would be treated as the carboxy. However, you can think then when your carboxylic acid is at the top position in the priority table, then how it can form the side chain? Remember, it will form the side chain, and when it will form the side chain, I will discuss that particular example also. But timing, you should know that when it is treated as a side chain, you will name this COH as the carboxy. When it will be treated as the functional group, principal functional group, then the name of the compound would be the oic acid. And second is the derivative of your acid, which is your acetic anhydride. This is a special case, and in that case, your see this is the very special case. I'll come to the later on this particular acidic nomenclature of the acetic anhydride. Timing, you can skip this one, right? And third very important functional group is the ester, which is again the derivative of this carboxylic acid. What is the meaning of the derivative? See, this is your COOH. When I replace the hydrogen of this carboxylic acid with this R could be your anything. R is your alkyl group, right? It may be your CH3, it may be your C2H5 and all these things, right? So it will be your ester, and when ester is present, then name of the functional group, that is the IUPAC name of the compound, when it is present as the secondary suffix, then the compound name of the compound would end at O8. O8 is the name of the principal functional group when it is treated as the secondary suffix. But when, say, your compound is having this acidic functionality and it is also having the ester functionality, right? Two functionalities, see, two functional groups are there in your compound, carboxylic acid and your ester, then your carboxylic acid would be the main functional group and the name of the compound would be the oic acid, and in that case your ester would be treated as a side chain, and when ester would be treated as a side chain or the prefixes, then the name of this ester is the alkoxycarbonyl. See, if methyl is there, then it would be methoxycarbonyl. If C2H5 is there, then it would be ethoxycarbonyl when this ester is forming the side chain or the prefix, and this will only happen when your compound is having the carboxylic acid or the acetic anhydride, because they are placed at the top at the top of the periodic table, right, compared to this ester. After that, another very important derivative of the acid is the acid halide. So when I replace this OH part of this acid with the halogen, that is COX, then it will form the acid halide. So here I am writing the acid halide, but I am going little bit, see, I am showing this Cl here, and when I will write this Cl, then it would be your acid halide, acid chloride, and when I put the bromine here, it would be your acid bromide, right, or you can say the acidyl bromide, right. And when your acid halide is there, and when it is the only functional group present in the molecule, then definitely the name of the compound would be oil chloride. Like if you have the two carbons and they are forming this acid halide, then ethanoyl chloride would be the name of the compound. But if your compound is having this acid halide as well as your ester, then your ester would be treated as the main functional group and acid halide would be treated as the prefix. And when the acid halide would be treated as the prefix, then its name would be chloroformyl. It is again very, very important. Say, for example, your compound is having the acid halide functionality, it is also having the ester functionality, it is also having the acid functionality. Then your acid would be the main functional group and the name of the compound would end with this name, oic acid, and your ester and halide would be treated as the side chain or the prefixes, right? And next very important derivative is the acid amide, and the formula of the acid amide is the CONH2. What I have done, I have replaced this OH of the acid with the NH2 to make your acid amide, right? And when only this acid amide is present or this amide functional group is present in your compound, then the name of the compound would be your amide. If see, one carbon is there, you know, for one carbon it would be your methane, and this forming your amide, and this functionality is also there, then it would be methanamide. If two carbons are there, then it would be ethanamide, right? But see, if it is a little bit complex and difficult for you, don't worry about that. Whatever I am telling you, you try to note down the things, or you can take the snapshot of this lecture. Later on, when you will read your book, then you will be able to understand all the things what I am explaining right now here, right? This is very, very important. And after that, your cyanide is there, right? When cyanide is there and it is treated as the side chain, then it is the name of this cyanide is your cyano, right? And when it is treated as the functional group, then its name would be nitrile. This is Le, this is nitrile. Similarly, if your compound is having the aldehyde, right, and the functional group for the aldehyde is the CHO, and when it is forming a side chain or the prefix, then its name would be the formyl. And when it is the only, this aldehyde is the only functional group present in the molecule, then the name of the compound would end as al, right, like methanol, ethanol, propanol, butanol, etc. Similarly, your compound may have this functionality, which is the ketone, and when ketone is there, then when ketone is present as a side chain, that means when your compound is having the ketone functionality as well as any other functional group which is placed at the top compared to this ketonic group, then this keto would be, or this C double bond O would be treated as a side chain. When this CO would be treated as a side chain, its name would be either keto or oxo. But when your compound is having only this functionality, then the name of the compound would end with -one. Like you are having 3 carbons and you are having the carbonyl functionality in it, then the IUPAC name would be the propanone, right? Later I will come the detailed nomenclature of the ketone as well. Similarly, if you have the OH functionality, which this is where actually the alcohol, and when this alcohol is present with any of the functional group which are placed at the top position compared to this alcohol, then your alcohol would be the side chain, and other functional group which is placed at the top in the priority table would be treated as the main functional group. It is very, very important. So this example is rather important because this is OH and this is CHO. When this OH is treated as a side chain, then the name of the compound would be the hydroxy, okay, or the name of the prefix would be the hydroxy. And when it is the only functional group present in the molecule, then the name of the compound would be the ol. Like you can see the methanol if you have CH3OH formula, ethanol if you have the C2H5OH formula. But it is very important to note that, see, be careful when you are writing the IUPAC name of the compound, because little change in the spelling will actually change the name of the compound, right? See, some people have the habit of writing this A like O, right? So you'll write all, and all means alcohol here. Your compound is having CHO, but you have a bad habit of writing A like O, then it would become all and your question will wrong. Okay, and similarly you may have the amines. When amine is present as the side chain, then its name is the amino, but when it is the only functional group present in the molecule, then the name of the compound will end with the amine. And then you are having the ether functionality, okay, please remember. So this is your ether functionality, this is O, and either side of the O you have the 2 vacant valencies, and you can add 2 groups right onto this one. So when this functionality, this ether functionality is present as the prefixes or as the prefix, then its name would be alkoxy. Like 1 carbon with oxygen, that is methoxy, 2 carbon with the oxygen, that is ethoxy. But when it is the only functional group present in the molecule, then the name of the compound would be the alkoxy alkane. So right now it is very, very important to you to understand these things, and if you find little difficult to understand these things, then believe me, you will be able to solve any kind of the problem after the completion of the lecture. So far I have explained you what is the word root, what is the primary suffix, right, and what is the secondary suffix, which is the functional group, and the priority table. When we consider one functional group as a side chain, when we consider the functional group as a secondary suffix. Okay, when your compound is having only one functional group, then obviously it would be the secondary suffix, and you will use these names. Right? And when your compound is having more than one functional group, then the functional group which is placed at the top position in the periodic table would be the principal functional group, and the other groups would be treated as the prefixes. So far, so good. Now you can see see in the earlier example which I have written here. So you can see here these 2 are the prefixes, because you know your compound is having this functional group CHO, which is your aldehyde, and this is OH alcohol functionality, but in the priority table this CHO is at the higher position than your alcohol. So this would be the main functional group, and main functional group would be treated as the secondary suffix. The name of the compound would end with the al, and this is the double bond present between the 2 carbon atoms. This is the primary suffix, right? And these 2 would be treated as the prefixes or the side chains, and you will write these side chains first, right? So I'm coming to this point again, and 5 carbons are also there, right? And when 5 carbons are there, then the word root would be the 5 in that case. Please remember, okay? And this point is very, very important. See, up to this point actually, which up to this point, see, whatever the lecture I'll upload on the IUPAC nomenclature, these 20-minute things I'll add in each and every lecture of IUPAC nomenclature, so that new students will also be able to learn actually what I have explained in the previous lecture. So these 20 minutes will always be there in my every lecture of the IUPAC nomenclature, right? So now the question comes, how we can write the IUPAC nomenclature of this particular compound. So sequence to be followed, or sequence must be followed in order to write the correct IUPAC name of the compound. So if you have this particular example, right, say this, you have this particular example, so what you will write first? So according to the IUPAC, you will always write the prefixes first. So I will say, I have written here prefix and prefixes. More, if only one side chain is there, it is prefix, and more than one side chains are there, then it is prefixes. So you will write the prefixes first, and you will also denote the position of the carbon or the number of the carbon on which actually this prefix is actually resting or is bonding, right? And that position of the carbon would be termed as the locant. So first of all, you will write the prefixes, that mean these two, and their locant, that mean the number of the carbons on which they are forming a bond, or to which they are forming the bond, or on which they are resting, okay? And you will also follow the alphabetical order when you will write the prefixes, right? So your OH is the side chain, so it is hydroxy, which starts with the H, and this is also the side chain, which is bromine. It will start with the bromine, bromo B. So B actually comes first in the alphabetical order. So first of all, you will write the bromo, and after that you will write the hydroxy. So you will always follow the alphabetical order, okay? And then you will write, after the completion of these prefixes, then you will write the word root. Word root means number of carbon atoms present in the main chain of the compound. Once you write the word root, then you will write the primary suffix. Primary suffix means the kind of the bonding. See, it is very, very important when your compound is having double or the triple bond. So you will write immediately after this word root, you will write the primary suffix, and you will also give the locant, or you will also write the locant of this primary suffix, that means on which carbon actually this double bond is going to start, or is this double bond is there, okay? And once you complete with this one, then you left with the functional group only, then you will write the name of the functional group or the secondary suffix. So this is very, very important. This is very, very important for all of you. So I don't know how much you understood, right? But I am believing that you are grasping the things, right? So based on the discussion which I have discussed, right, which I have discussed to you, I'll try to write the IUPAC nomenclature of this one. See, if you find difficult, then don't worry. It is the little difficult compound for the beginners, okay? And later on, you will understand all the things. So how I can write? So first of all, I am giving the number to this carbon chain. So this is your carbon 1, this is carbon 2, this is carbon 3, this is carbon 4, this is carbon 5. And I know lots of the beginners who are watching this video, they are wondering why actually I have started the numbering of this carbon chain from the right hand side. I can start, or say I could start this from this left hand also, but believe me, this is the correct way of writing, of giving the number to the parent chain. Later I will discuss how we generally do these things, right? So I have numbered this one. So first of all, see, now these are the two prefixes. So first of all, I have to write the name of the prefixes. So how I can write the name of the prefixes? See, at 2 position you are having the bromo. So you will write 2 dash bromo. It is very, very important. Guys, please remember it is very, very important to note that whenever you are writing the IUPAC nomenclature, then your numeric value and your alphabet must be separated by this dash or the hyphen, whatever you say. So this is 2-bromo because at position number 2 your bromine is there, right? And then again dash 4-hydroxy, 4-hydroxy, right? Why? See, at position number 2 you are having the bromine, and the name of the bromine as a side chain would be the bromo because it is negatively charged ligand, and negatively charged ligand, name of the negatively charged ligand generally ends with the bromo, right? But you can write, see, halogen are always written as bromo, chloro, ido and fluoro, etc. And at the carbon number 4 you are having the OH group as well. It is also the side chain. So 4-hydroxy, when it is treated as the prefix, then its name is the 4-hydroxy. So you have done with this prefix along with the locate. Now you have to write the word, and be careful and see, I have written this B bromo first because alphabetically B comes first, right? And once you're done with this, then you will write the word root. Word root means number of the carbon atoms present in the molecule. So you can see here how many carbon atoms are there in the molecule. Only 5 carbons are there, right? And for 5 carbon, the word root is pent. So I'll write P-E-N-T, pent, connected with this Y, pent. And you can see here at the position number 2, you are having a double bond, right? Then see, you have done this, you have written this word, then you have to write the primary suffix, that is the type of the bonding, especially when it is the double and the triple bond present in the molecule. And of course, this molecule is having the double bond between the 2 carbon atoms. So you have to write this primary suffix, right? And you will also write the locant of this primary suffix. So locant is what? That means the carbon from which actually this double bond is starting. So from carbon number 2, it is going to start, right? So you will write dash 2 dash ene. You know, when your double bond is present in the molecule, see, for single bond, the suffix is ane, primary suffix is ane. For double bond, the primary suffix is ene, E-N-E. And for triple bond, primary suffix is yne, Y-N-E. But I'll not write the terminal E here because IUPAC nomenclature says that if you write E here, then you have completed the name of your compound, but the name of the compound is not completed yet because you didn't write this functional group, and you have to write this functional group as well. So I have to write this functional group, and to write this functional group, I'll write this dash 1 dash ul. Remember, when aldehyde functionality is there, then the name of the compound would end as the ul. I can go back to show you again. You see here, this is my aldehyde functionality, and when it is the main functional group, then the name of the compound would be ul, right? That's why it is very, very important I have written this ul here. So this is the complete name of this particular compound: 2-bromo, 4-hydroxy, pent-2-ene, 1-ul. See, this A is actually what? Vowel. What are vowels? You know, A, E, I, O, U. When see, please wait, U. So when the name of the principal functional group or the secondary suffix starts with the vowel, then you will not write terminal E here. But when the name of the functional group starts with the consonant other than E, I, O, U, then you will write the terminal E as well here according to the IUPAC nomenclature. But I know for the beginners this example is little bit difficult, right? Because I didn't tell you how to name the compounds having the functional group, right? So I hope up to this point there is no problem, right? It is my 6th lecture on the IUPAC nomenclature of organic compounds, and In this particular lecture, I am going to discuss how to give name to the compounds which have the functional groups of the esters, acid halides or the amides, right? If you can recall, in my last lecture, I have completed the IUPAC nomenclature of the acetic anhydride, right? So if I go back, then I can show you. This was my lecture number 5, where I have completed the IUPAC nomenclature of your acetic and acid anhydrides, right? And for this particular lecture, I am giving you the link in the description box, and it is my advice to you as well. If you are watching this video for the first time and you are actually start learning to organic chemistry, say you are in class 11th students, or you are new to the organic chemistry, so it is very important for you to learn the IUPAC nomenclature right from the beginning. And for this, what you have to do, you have to go through my earlier lectures on the IUPAC nomenclature, where I have explained all the basic rules which are generally applied to give the IUPAC name to any organic compound. This is very important, right? I am giving you the links in the description box of my earlier 5 lectures, so that you can learn the basics from the lecture 1, right? So without wasting too much of time, I'm quickly jump into the topic. And first I'll start the esters, the compounds which have the ester functionality, right? I'll give the IUPAC name to this particular compound, right? So whenever you have the ester, so you first of all you have to identify the ester functionality. As I already told you, this carbonyl group is very common in many compounds, right? It is there in the ketones, it is there in the aldehydes, it is there in the acids and all the acid derivatives. So it is very important for you to clearly identify the types of the functional group. So functional group in the ester functionality, you can see it is like that: carbonyl group connected with the oxygen, and that oxygen is connected with the alkyl group, right? R. It is not necessary that always you will find R here. You may also find the aryl functionality, like phenyl or the substituted phenyl, or your cyclohexane system, cyclopentane system, anything you can find, right? And this is the vacant valency of the carbon, where you will attach your next alkyl moiety or cyclo alkyl moiety, whatever you want, then you can attach here. See, for the sake of the practice, what you can do, you can draw the lots of the structure. It doesn't matter whether you will be able to synthesize that particular molecule in the lab or not. It doesn't matter actually. It is for your practice, that if you have more number of the problems, whether it is whether the structures are theoretically possible or the practically possible, it doesn't matter. It will give you the immense confidence to you when you practice such type of the molecules, right, by giving name to them. So first of all, it is your work to identify this functionality. And general formula, GF is the abbreviation for the general formula for the esters are R C double bond O O R. But this R and this R, they both may be the alkyl group, they both may be the aryl group. One alkyl and one aryl, one cycloalkyl and one aryl, any combination you can use here, right? And what is the method to give the IUPAC name? So the IUPAC name of the esters are generally alkyl alkanoate. Alkyl alkanoate. Then what is the meaning of that? Earlier you have seen, whenever you have the carboxylic acid, like you are having the acetic acid CH3COOH, for example, say you are having this particular molecule CH3COOH, right? So this is carbon number 1, this is carbon number 2, and if you want to write the IUPAC name of this compound, then it would be your ethanoic acid, okay? And when you actually replace this hydrogen with any other alkyl group, you will end up in the formation of your ester functionality. So here you can see, if you substitute this with this CH3, then it would be your ester. So how to name this ester? What you will do, you will actually replace this oic acid term, right? This is your oic acid term, and this oic acid term you will replace with the O8. So then you will have what? Ethanoate, apart from the alkyl group, right? And that alkyl group comes from this substitution. First of all, you should know this thing actually, right? Now quickly jump to the IUPAC nomenclature. So in the alkanoic acid, you will replace this oic acid with the OH, and this alkyl actually comes from that alkyl part which is connected with the oxygen, right? So if you want to, this is the simplest way, right? And selection of the longest continuous chain, and how to number the longest chain, and how many types of the different types of the prefixes you can write, right? All these things I have explained in my earlier lectures, but don't worry, if such problems are there in my current lecture, I'll explain these problems again and again. Okay, so first of all, if you want to give the IUPAC name to this particular compound, right, and the compound is this one. Okay, so what you will do, so first of all, you should always remember this part actually which is written on the right hand side and connected with the oxygen. This comes first, and this is your alkyl group, and the name of this alkyl group will always be written first, as I have explained here, alkyl. So now suppose you have to write this one. So this is having only one carbon, which is the alkyl group, comes from the methane, it is methyl, right? So you will write for this methyl. Okay, this is the way of writing IUPAC nomenclature. Then you left with this moiety, and this moiety is what? Alkanoate. So first of all, you have to find the alk part, that means the word root part on this particular left hand side. So how to do that? Say this is your carbon number 1, this is your carbon number 2. This is actually the bond line notation, and this carbon is hidden here, but you should know this is carbon here, and this is again carbon. When you have the one line like that, this shows the methyl, right? So 1 carbon and 2 carbon, that means word root is 8th, right? For 2 carbon, word root is 8th, right? And since both these carbons, this carbon and that carbon 1 and 2, they are connected with the single bond, and when they are connected with the single bond, that means ane you will use as primary suffix, and after that you will write O8. O8 is for the ester functionality. So the correct IUPAC name of this particular compound is the methyl ethanoate, right? I hope this makes the sense. Now you are having the second compound, and in the second compound you can see this is the alkyl part which is present on the right hand side, and you have to write that part first, right? And then you will part the alkanoate part, and for this alkanoate part you will write carbon number 1 here, carbon number 2 here, and carbon number 3 here. And you can see here, this is 1, this is 2, this is 3, this is 4, right? 4 carbons are there. That means it is, this alkyl group is the derivative of the butane, so it is butyl. Okay, and after butyl you can see 1, 2 and 3 carbons are there, so you will write prop for 3 carbon, and then you can see all the 3 carbons are connected with the single bond, that means it is the alkane moiety, so you will write the ane, and O8 is the O8 is for the ester. So the correct IUPAC name of this particular compound is butyl propanoate. I hope this is quite clear to you. Now again you can see what you can do. Next problem number 3, that part, right? This part is connected with the oxygen, so you will write that part first. Okay, first it will be written, and after that you will write that part, because it is the derivative of the benzoic acid, right? So how actually we can write, say this particular molecule is there, you all know this molecule is the benzoic acid. So if I substitute that hydrogen with this group like CH3, CH and CH3, okay, so I'll end up in the formation of this one. So this compound is the derivative of the benzoic acid, right? When it is the derivative of the benzoic acid, so how we can name it? So first of all, now this problem is little bit important for you, because this is the side chain, and this side chain is very complex. Basically it's a isopropyl group, okay, but in the IUPAC nomenclature you have to give the correct name to this particular side chain, particular alkyl group as well. So the carbon which is directly connected with the oxygen will always have the priority, higher priority, that is the priority number 1. So this is carbon number 1 and this is carbon number 2. So in that way you have covered only 2 carbon, but this carbon is left again. You cannot number it, or however you can go in that manner also. This is carbon number 1, say this is carbon number 2, then you will left with this one with unmarked actually, or unnumbered. So this will not make any difference whether you number this 1 and 2, this will leave without number. If you number it 1 like that, 1 and 2, then this will be without number, but both will be the same. So how, first of all I have to write this one. So how I can write this one, it is very, very important. See, at one position you are having methyl substitution. This is your 1 methyl, okay, and dash ethyl. So this is the name of this side chain. After that you can see this is the derivative of the benzoic acid, right? So you will write bench, and since the 2 carbons, 1 carbon of this benzene and 1 carbon of this carbonyl group is connected with the single bond, that means it is again what? Ane, and then you will write O8 for this one. So the correct IUPAC name for this particular compound is 1-methyl-ethyl benzoate. However, you can also write isopropyl benzoate. See, if you write like that, isopropyl benzoate, then this will also be correct actually, right? So this is important. This is very, very important. Now moving to the next one, right? Now draw the structure of the following compounds. So see, generally what happens in your competitive examinations or your academic curriculum, like your 11th and 12th, right? So you may not always have the question like that where you have you will have your structure and then you have to write name. The examiner can ask you the question in the another manner as well. He can write the name of that particular compound and you have to draw the structure. So methyl acetate, and I already told you what you have seen in the earlier problems, that part which I have written first actually, right? It is connected with the oxygen, right? This you have to keep in mind. So what I will do here, methyl is written first. So when the methyl is written first, so what I will do here, I'll write CH3 for that methyl, okay? And it is connected with the acetate. So acetate part means this oxygen, right? And this carbon double bond oxygen, and this is CH3. How it is acetate actually? You know what is acetic acid? CH3, C double bond O, OCH3, OH, sorry. This is your acetic acid. When I replace this CH3, this H with the CH3, then you will end up with this one. So basically this is what? This methyl acetate, the structure of methyl acetate is like that, and if you go back, then you will see here this particular compound. This is also methyl acetate, and the IUPAC name of this methyl acetate is what? Methyl ethanoate. So here this structure methyl acetate is nothing but it is the methyl ethanoate. Methyl for this one, and carbon 1 and carbon 2, this is the ethanoate part, okay? And then you have to draw this ethyl pentanoate. So you have to write ethyl first. So for ethyl you will write what? C2H5. There is no problem in that, and you know that part is always connected with the oxygen in the ester moiety, and that would be connected with the carbon double bond oxygen. So 1 carbon is already there, but you have to write pent. Pent means total 5 carbons. So 1 is there, this is carbon 2, this is carbon 3, this is carbon 4, and this is carbon 5, okay? And then you have to complete its valency. So it is your CH3, and then this would be your CH2, and this would be your CH2, and this would be your CH2, right? So this is how I have completed the tetravalency of the carbon as well, right? So if you are earlier here and watching video for the first time and you find little difficult how I am actually doing this, how I am completing this valency by adding the hydrogen. So for very new student, it is very important to note that whenever you have to complete the valency of the carbon, right? So you have to add hydrogen to make the carbon tetravalent. Okay, this is very, very important. So this carbon is here. This is valency number 1, which is a bond. This is valency number 2, that is second, and then 3 and 4. Similarly, this carbon is connected with this single bond. So this is valency 1 and 3 hydrogens, 3 and plus 1, 4. So this is ethyl pentanoate, the correct structure for this particular compound. Okay. Now moving to the next problem. Ethyl benzoate. Benzoate means, see, ethyl means what? C2H5. And it will always connected with the oxygen, and that oxygen in turn connected with the carbonyl functionality, and then your benzoic acid part, that means benzoic part. So this is your ethyl and this is the benzoate part, right, because it is the derivative of the benzoic acid. Okay, then next is your phenyl benzoate. Phenyl benzoate. So phenyl means what? Phenyl means again the benzene ring, and it is connected with the oxygen here, and then your carbonyl functionality, and again you see this benzoic acid part. So this is your phenyl, okay, and that part is the benzoate part. So this is how you can name this particular compound as well. Now you can see here I am going to solve a particular very important problem. Why this problem is very, very important? The problem number 5. You can see here, this is C double bond O OH, that is, this is acid. This is the acid part. Okay. And that part, see, if you see here, this carbon double bond oxygen, this oxygen, this is your anhydride part. See, if you have followed my earlier lecture on the IUPAC nomenclature of anhydrides, then you will be able to know that carbonyl group, 2 carbonyl groups connected with the oxygen, it is basically the anhydride functionality. So this molecule is having the anhydride functionality as well as the acid functionality. That means 2 different functional groups are present. And whenever the 2 different functional groups are present in the compound, then you have to name that compound in the way that in the priority table, that functional group which is at the top, the principal, the name of the compound will actually according to that functional group which are at the top position, or say relatively top position in the priority table, right? So here this acid is present at the top. This acid is present at the top, and after that here comes anhydrides. So your compound is not this time your ester or anhydride, this is your acid basically. This compound is your acid. So how we can name this particular compound? So first of all, you should know how to name it. For this, say this is carbon number 1, right? This is the acid part. So basically it is what? Methanoic acid part. Please remember, it is the not methanoic acid part, I'm sorry. But you need to identify that functional group. Okay, this is carbon number 1, and say this is carbon number 2, and this one is carbon number 3. They all are coming in the long chain. Selection of the longest continuous chain which will have the multiple functionality or the functional group. So this functional group is the acid. This is CH2. This is your carbon double bond oxygen. Now again this is your what? Oxygen. So you cannot number it, because the rule says that we have to select only that carbon chain, that chain which has only carbon in the backbone. So carbon actually are present only on these 3 positions. Now this carbon 3 is having this substitution. So if I write like that, this carbon 3 is having this substitution. So first of all, you need to write that substitution, and that substitution is actually starting from the position number 3, because this is carbon number 3. So you will write 3 dash, okay, and then this is the part of the, see, this is CH3, this is C double bond O. So this is your acetic acid part. That means it is acid part, and along with the oxygen, so you will write it as 3-acetoxy. Acetoxy. Why acetoxy? Because acetic acid part is there, and this is along with the oxygen, so this is acid and then oxy. So 3-acetoxy, and then you will close the bracket because you have written this particular name, and then the remaining functional group you can see here. This is position number 3. Now since you have named this one, you left with this carboxy group or the keto group at the position number 3, right? Because it is present in the chain as well. So you will write 3-oxo, or instead of the oxo you can write the keto as well. So you have completed, you have written this functionality, you have written this functionality, and then you left with the carbon chain. So how many carbon chains? 1, 2, how much carbons are there in the chains? 3 carbons are there. So you will write prop for this one, and all these 3 carbons are connected with the single bond. So of course it is your ane. So you will write ane, and this is your acetic acid part, that is oic acid part. So this is your oic acid. So this is how you can name this particular compound, 3-acetyl oxy, not acetoxy, I am sorry, acetyl oxy. Please, I need to correct it because that is acetyl part, right? 3-acetyl oxy, 3-oxo propanoic acid is the correct IUPAC name of this particular compound. Okay, I hope you understood the problem. So in that case, you have 2 or 3 different functional groups, ketone, esters, or if you take, see, this is your ketone, this is your ester. If you take all together, then it is anhydride. It is a very complex type of the compound. But in the priority table of the functional group, this acid is at the topmost position. So this is the principal functional group. Thus, the name of the compound will be according to this principal functional group, that is acid, oic acid, and remaining would be your remaining functional group would be treated as the side chain. So I have treated them as side chain. I hope this is clear to you. Okay. Now since I need some space, so I am removing this one. You can take the snapshot. Right. Now I left with this problem number 6. So how I can name it? Again, you can see a very important fashion here. This acid part is there. Okay, this acid part is there. Okay, this acid part is there. Along with the acid, this ester moiety is also there. So ester and acid both present together, but in the priority table, acid is at the top position, and this is actually not, this is comes after the anhydride, right? So this would be treated as the side chain, and this would be treated as the principal functional group. So your compound name would be oic acid, but not ester, not OA type. Okay. So how I can give name to this particular compound? Again, it is something very, very important. So say this is carbon number 1, this is carbon number 2, and this is carbon number 3, and that carbon number 3 is having that substitution. Okay, that substitution of benzoic acid. So what you will write here, 3 dash benzyl oxy. Benzyl is for benzene ring, and then this is your oxy, right? So this is 3 benzyl oxy, bracket close, and then 3 carbons are there in the main chain, that is propane. This is 1, this is 2, this is 3. All these 3 are connected with the single bond. So it is what? Pure alkane. So we'll write propane, and for acid you will write the oic acid. So the correct IUPAC name of this compound is the 3-benzyloxy propanoic acid. Okay. Now moving to the next. Now see, I have covered the IUPAC nomenclature of the esters. See, if you want, then you can draw the several structures by your own and try to write the IUPAC name of them, right? And if you find difficulty in understanding, then you can comment in the comment section. I'll reply when I get time. Okay. So this is ester completed. Now next important derivative of your acids are what? Acid halides. Okay, acid halides. So now this is your acid halides. Okay, so what is the functional group of the acid halides? This is carbon, double bond oxygen and Cl. So in my lecture number 4, I think, where I have explained the IUPAC nomenclature of the acids, I have also explained you to how to actually convert the acid into the corresponding functional groups like ester, acid halides, anhydrides, amides, all these things. Okay, so but since I'm assuming that some new students also joined this particular lecture, so they should know actually, if you have this acid CH3COOH, right, and if I replace this OH with the X means the halogen, which could be your Cl, which could be your Br, which could be your I. Fluorine is generally not there, okay, but you can write, you can attach fluorine as well for the sake of the practice. So what would be the name? What would be the structure then? CH3COX. This is your acid halide, and more correctly you can write CH3C double bond OX. If this is X, if this X is chlorine, then it would be your acetyl chloride, acid chloride. If this is Br, then it is acid bromide. If this is I, then it is your acid iodide. I hope this is clear to you. Again, I am removing this one because I need some space. Since monsoon has started now, so I am having problem because I am allergic to the moist conditions. So that's why I am finding little difficult in delivering good voice, okay, or clear, not good, rather clear voice, okay, right. So let's do the job. So this is your carbon, double bond oxygen. This is the vacant valency where you can attach the alkyl or the aryl group. This is the chlorine, right? This is your acid chloride, right? And if you replace this chlorine with the bromine, then it is bromide. What is the general formula for the compound? RC double bond OCl, or you can add the benzene ring as well. Okay. So how will write the IUPAC name of this compound? Alkanoyl halide would be the IUPAC name of this compound. Alkanoyl halide. So how I have produced this name, right? This is the alkanoic acid, and when you replace that oic acid part with the, see, this is ic acid, so ic you will replace with yl, acid you will replace with the halide, so il halide. So after O you will add YL, so alkanoyl, and then this is the halide, right? This is how we can write the name. So say for example, if you have this particular compound, how to name it? Clearly it is what? Bromide. It is your acid bromide. Okay. So first of all, you have to select the longest chain of the carbon atom which contains the functional group. So this is carbon number 1, this is carbon number 2, this is carbon number 3, and it is the rule as well. You will always give the functional group at the lower, you will always give the lowest possible number or the highest priority to the functional group. That's why I have started a numbering from here. You cannot do like that. See, 1, 2, 3. Then this blue numbering is the wrong one. You will never start the numbering from the left hand side whenever you are dealing with the esters, acid anhydride, halides and the amides. You will always start numbering with starting from the carbonyl carbon. Okay, so I am removing it. So how I can name it? So alk. Alk means word root. So 3 carbons are there in that case. So the word root is what? Prop. For 3 carbon, word root is prop. And all these 3 carbons are connected with the single bond. That means it is the derivative of the saturated compound. So this is propane. Okay. And then you will write the oil. So this is propane oil. And halide, this is bromine. So you will write the bromide. So the correct IUPAC name of this compound is the propanoyl bromide. I hope this is clear to you. Similarly, you can write the IUPAC name of this one: 1, 2, 3 and 4. Okay. So if you are new here and finding little difficult to understand, so I am writing this structure: CH3, CH, this is CH3 again, Okay, this is carbon double bond oxygen, this is chlorine, they both are same. This is structure and that structure, they are same. So this is what? Carbon number 1, carbon number 2 and carbon number 3. If you want to give number, say 1, 2 and 3. So this is what your side chain or the prefix. So this is your prefix, which is what? Which is your methyl. Okay. So how I can name this particular compound? So I am removing the things which I have explained to you. Okay, removed. Right. So here you can see the 4 carbons are there. So when your 4 carbons are there, and so it is the part of your butane. But IUPAC nomenclature says that you have to write the prefixes first, and your prefixes is what? Methyl at the position number 2. So you will write 2 dash methyl. Right. And after that you can see 4 carbons are there. So you will write but for 4 carbons, and all these 4 carbons are connected with the single bond. Then you will write this is your N, and since this is the acid halide, so you will write oil, and this is your chlorine, so you will write the chloride for this one. So 2-methyl butanoyl chloride is the correct IUPAC name of this compound. Then you left with this one. This is rather looking complex one. How we can name this particular compound. So this is however there are 2 ways, right? So here you can see this is your acid halide functionality, and that part is your cyclohexane part, right? So you can write it like that, cyclohexyl. ठीक है, cyclo, not hexyl actually, cyclohexane part, cyclohexanoyl chloride. This is the correct IUPAC name of this compound. Okay, and sometimes you can also write like that, cyclohexane carbonyl chloride. So there are 2 ways in the literature where you can find the name of this particular compound, but according to me the first one is more correct. However, the second one is not wrong, but first one is the more correct one. Cyclohexanoyl chloride is the IUPAC name of this compound, right? So how it is actually cyclohexanoyl compound? Because it is the derivative of this particular compound. It is hexane carboxylic acid. What is the IUPAC name of this compound? Cyclohexane carboxylic acid. Carboxylic acid. This is the IUPAC name of this compound, right? Or you can write in that manner as well, cyclohexanoic acid. Cyclohexanoic acid, right? For this particular one. Forget about this part. This actually comes in the acidic part. This is a little tricky actually. You need to practice such tricky examples as well. Okay. And then you are having your next problem, which is this one. Now this is looking little bit complex. So first of all, you know this bromine is there, which is connected with the carbonyl carbon. So basically this is your acid bromide, and that part is the carbon chain part, which is the complex one having the multiple substitutions or the prefixes. So what the rule says that selection of the longest continuous chain of the carbon atom. So this is carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 4, this is carbon number 5, this is carbon number 6. Or if you want then you can give a 6 to this particular carbon. This will not make any difference, right? In both way you will end up with the same type of the compound. Okay, and then you can see here this bromine is here. So basically it is what? Your bromide, acid bromide is there, but this is quite complex. When it is complex, so you have to write the prefixes first. IUPAC nomenclature says that you have to write the IUPAC nomenclature of the, sorry, you have to write the prefixes first in the IUPAC nomenclature. So here you can see that part is the methyl part, okay, and that part is the iodo part, and that part is the chloro part. So in alphabet, C comes first, after that your I will come, and after that your M will come, and you have to follow the alphabetical order as well in the while doing the IUPAC nomenclature. So how I can write it? Write this, okay? Wait. Right. So at the position number 3, you can see here, at this position number 3, this chlorine substitution is there, as well as this at position number 3, iodine substitution is there. So you will write like that, 3 dash chloro dash 3 dash iodo. And in the IUPAC nomenclature, you will remember your alphabet and your digit must be separated with that dash. Please remember, okay? So 3 chloro, 3 iodo, and then you can see at the position number 5, you are having another substitution, which is methyl. Okay, so all these are prefixes, 3 chloro, 3 iodo, 5 methyl, and then you are having the 6 carbon atoms in that part. Okay, 6 carbon atoms are there. So 6 carbon atoms means you will write hex for 6, HEX, hex. All these are connected with the single bond. So it is what your hexane, so hexane, and then your oil bromide. So the correct IUPAC name of this particular compound is 3 chloro, 3 iodo, 5 methyl hexanoyl bromide. In the similar way, you can write the IUPAC name of this particular compound as well. Since I need some space, so I am removing it again. You can take the snapshot. So how I can give the IUPAC nomenclature to this particular compound? Now this is your acid halide. Please remember, this is your acid halide and this is your ester functionality. And in the priority table of the functional group, this ester is the top position relative to this acid halide. So your principal functional group is the ester. So your compound will not be your oil halide. This would be your alkanoyl OH, alkanoate, right? Alkyl alkanoate, because ester functionality is at the relatively top position that when compared to the acid halide in the priority table of the function group decided by the IUPAC. So how I can give IUPAC name to this particular compound? So first of all, selection of the longest continuous chain of the carbon atom, which is this one, 1, 2, 3 and 4. This is the principal functional group. And then you can see here, this is carbon number 1, or this is not 1, because this is the principal functionality. So this is carbon 1, this is carbon 2, and this is carbon number 3. So this part actually is the prefix or the side chain part, and you have to write the side chain first. So when you will write the side chain first, how you can write the name? Okay, so this is substituted, right? This is substituted. So how you can write like that? Okay, so it is what? Chloro 1, it's not 1 actually, you can write straightforward. Chloro, there is no problem, right? And then this is your carbamoyl, chlorocarbamoyl, right? And then the bracket close. Okay, and you can see at that carbamoyl, this is actually chlorocarbamoyl part, right? So see, if you find little difficulty in understanding, let us go back and I can explain you. So this is C double bond or Cl. Please keep this in mind, and I'm going back. Here you can see this is your acid halide, C double bond OCl, When it is principal functional group, that means secondary suffix, then the name would be oil chloride. But when your COCl is present as the prefix, then its name would be chloroformyl. Sorry, the chloroformyl. Name would be chloroformyl. So I made a mistake. It is chloroformyl. Okay, not chlorocarbon oil. It is chloroformyl. So I'll check this one. Okay, so chloroformyl you will write for that. Okay, so right here I am coming again. So I am deleting it. So chloroformyl. It is what? Chloroformyl. And that chloroformyl part is attached to the carbon number 2. So we will write 2-chloroformyl. Okay, and then the bracket close. And then you can see here, this is this part actually is the alkyl part of your ester moiety. Since 2 carbons are there, so you will write eth for this one and il, that is ethyl. And then you can see 1, 2, 3, 4, 4 carbons are there. So for this 4 carbons you will write but, and all these are connected with the single bond. That means it is butane and it is the ester functional group, so butanoate. So the correct IUPAC name of this particular compound is 2-chloroformyl ethyl butanoate. Please remember, I am repeating all the things. This is the acid halide functionality, this is ester functionality. In the priority table it is at the top, so your compound will always be ester. That means the name of the compound will end up with the O8, right? And when this C double bond or Cl is present as present as the side chain, then its name is the chloroformyl and it is connected with the carbon number 2. So this is 2-chloroformyl and these 2 carbons are there, which forms the ethyl part, and this is your ester moiety with 4 carbons, so butanoate. This is the correct IUPAC name of this particular compound. This is how this IUPAC nomenclature is very, very important and very, very interesting. I am telling you the incident of yesterday, where in one of my group someone has asked how to name this particular compound, and it was a simple alkene, and I made a mistake in answering. So it happens when you don't do the practice, then the rules will escape from your mind. So it is very, very important to revise the topic. Revision is the only key for any subject to learn. Okay, revision is the key to learn any subject. Okay, please remember. So now this is your next compound. Here you can see this is your acid halide part, this is your ester part, and this is your acid part. And in the priority table, this acid is at the top, remaining 2 are the side chains or the prefixes, but these prefixes are present in the chain. So this forms a very complex example. So how we can write the IUPAC name of this particular compound? This is quite challenging now. So say this is carbon number 1, this is carbon number 2, this is carbon number 3. So again there is no problem. At carbon number 2 you have present this functionality. This is what your bromoformyl. It is not chloroformyl now, it is your bromoformyl, right? And that bromoformyl is actually present at carbon number 2. Please remember. Okay, so I'll come to that again. And since you know your principal functional group is this carboxylic acid, so you will always give the lowest priority or the highest priority or the lowest possible number to this one. So you will not start numbering from that end, because it will put this carboxylic acid. See, if you start numbering from this 1, 2, 3, 4, 5, so your acid part would present at the locate number 5, which is wrong, because you have to give the lowest possible number or highest priority to this one. So you cannot start numbering from the left hand carbonyl carbon. You will always start numbering from here. This is carbon 1, carbon 2, carbon 3 and carbon number 4. So whatever the substitutions are there, it is actually present at the carbon number 4. So when the substitutions are present at the carbon number 4, so you will write the 4 first. 4 dash, then you will start bracket, and then you will put another small bracket, because you are having the two different functional group and you have to separate them. So you will use the two different parentheses for this one. Now you can see here at 4 position all the substitutions are there, and here again you see at position number 2 your bromo formula is there. So you will write 2 dash bromo formula. 2 dash bromo formula. I hope this is quite clear to you. Okay. And now see, you cannot write the bromo formula. Formula means derivative of the formaldehyde. But here you can see it is not the formaldehyde, this carbon chain is there. So carbonyl is there. So you will write the bromocarbonyl. Not formyl, you will write the bromocarbonyl. Bromocarbonyl. Because formyl means carbon single, just like that. This is your chloroformyl. When this hydrogen is not there and substitution is there, then you will add the chlorocarbonyl. Okay, that's why 4 2 dash bromocarbonyl and then the bracket close. Let us remove this. Okay. Now you can see here, this part is what? Ester part. Sorry. This part is what? Ester part. But it is not written like that, because when you have the ester as a side chain, so there is no way in writing this ester as the prefixes. So you have to separate this carbonyl as well as this oxygen part. Okay. So this is basically, you see 1 and 2 carbons are there, and that 2 carbon is connected with the oxygen. So it is your ethoxy. What? This is your ethoxy. So you will write ethoxy for this one. So once you write the ethoxy for this one, and after ethoxy, right, you are having this carbonyl group. Okay, ethoxy. So you will write ethoxy carbonyl. Right, ester you will always write, when ester is present as a side chain, you will write the ethoxy carbonyl. If 2 carbons are there, if 3 carbons, then propoxy carbonyl, not L. Let us remove this L from here. And if you have say 3 carbons, propoxy carbonyl, 4 carbons, butoxy carbonyl, like that only. So 4 parenthesis, again parenthesis, 2 bromocarbonyl, bracket close, ethoxy carbonyl, right? And you have to close the bracket for this one, because this is also the side chain. This is also the side chain. And then you can see total 4 carbons are there. Total 4 carbons are there. That means this is the derivative. The word root for this one is what? But. All 4 carbons are connected with the single bond. That is your alkane. So we'll write the butane and then oic acid. So whenever you have the ester or your acid halide and the acid functionality all together present in the compound, then you have to write the name of the IUPAC name of the compound, giving highest priority to the carboxylic acid group, because it is present at the top position according to the IUPAC. This is how you can write IUPAC, correct IUPAC nomenclature of the very complex compound as well. Now the last derivative of your acid is acid amides. So here you can see acid amides are there. So functional group of the acid, what you do, you will replace that Cl with the NH2. So earlier COCl was acid halide. When CONH2 is there, then amide, acid amide. General formula RCONH2 or ARCONH2. AR stands for the phenyl group. IUPAC nomenclature would be alkane amide. Alkane amide. That means terminal E of your alkane would be replaced by the amide. This is ester functionality, right? Sorry, this is your amide functionality. And for amide, you will use the amide. Remaining would be your alkane. So what you have done, where in the alkanoic acid, this oic acid would be replaced by the amide. So when you replace this oic acid with amide, you end up with the alkanamide. This is how you can write alkanamide from the alkanoic acid. So IUPAC name, how to give IUPAC name to this compound? Selection of the longest continuous chain of the carbon atom, and you will always start numbering of the carbon chain starting from the carbonyl group because it is the functional group, right? So how many carbons are there? 4 carbons are there, that means but, and all these 4 carbons you can see here, 1 2 3 4, all these 4 are connected with a single bond, so it is quite obvious it is butane, and after butane you will write amide here. So butanamide is the correct IUPAC name of this compound. Now let's move to the little bit difficult example, and how we can name that difficult example. So here you can see this is carbon number 1, this is carbon number 2, this is carbon 3, this is carbon 4, this is carbon 5, carbon 6, carbon 7, and then carbon 8. Okay, so this is the methyl substitution, that is prefix. This is also prefix. Okay, and this Br is also prefix. And in the IUPAC system, you have to write the prefixes first alphabetically. So alphabetically B comes first, so you will write 4-bromo. There is no problem in that. Okay, and at carbon number 7 you are having 2 methyl group, that means 7, 7 dash dimethyl, because 2 methyl are there, dimethyl. Okay, see, if you find little difficult to understand why I have written 7, for this you have to follow my earlier lecture. Okay, please remember, if you are new to the organic chemistry, right, then it is very, very important for you to learn the things from the basics, and for this you have to follow my lecture right from the beginning. Okay, so now 4-bromo 7 dimethyl. So this substitution I have completed at 4 position. At 7 position 2 methyls are there, so dimethyl are there, and then 8 carbons are there, and all these 8 carbons are connected with the single bond. So for 8 you will write oct, and they are connected with the single bond ane, and then you will write amide for this one. So the correct IUPAC name of this compound is the 4-bromo 7 dimethyl octanamide is the correct IUPAC name of this particular compound. Okay, now this is my last page. Now I have little difficult problems where your nitrogen is also substituted. This is amide, but this is N-substituted amide. N-substituted means nitrogen is substituted again. So selection of the longest continuous chain, 1, 2, 3 and 4. That means it is butanamide. Simple. But that butanamide is also substituted with this. So carbon number 2, 1 and 2. That means this part is basically what? This is ethyl part. When 2 carbons are there, then it is your ethyl part. Okay. So at position N ethyl is there. So you will write capital N ethyl. That means your nitrogen of the amide is substituted with the ethyl group. N ethyl, and after that you will write but for 4 carbons, and all 4 carbons are connected with a single bond, that is butane, and then amide. So N-ethyl butanamide is the correct IUPAC name of this compound. And then you have to write what? Cyclohexyl propanamide. See, propanamide is quite simple. See, this is your, say, carbon double bond oxygen. This is your NH2. This is amide functionality. This is carbon number 1. So this is carbon number 2 and this is carbon number 3. This is how you can write. Okay. This is carbon number 3. And at position number 3 you can see here cyclohexyl substitution is there. So at position number 3 you will add what? That cyclohexyl part. And then you have to complete the valency. So this is again you see CH2 and this is again your CH2. In order to make these carbons tetravalent, 1, 2, 3, 4, 1, 2, 3 and 4. Okay, so here you can see at 3 position cyclohexyl substitution is there, 3 cyclohexyl. Propane 1, 2, 3, that is propane and it is the amide. So this is how you can write you can draw the structure of structure from the name of the compound. Now your next problem, again it is now it is quite simple here. See, this is carbon 1, this is carbon 2, this is carbon 1, this is carbon 2. This nitrogen is substituted twice with the 2 ethyl groups. So this is N and again N, because nitrogen is substituted twice. N comma N dash diethyl, right? And this is carbon 1, this is carbon number 2. That means it is the derivative of the ethane. So this is eth, not derivative, but the word root is eth, and connected with the single bond, 2 carbons, N and then amide. So N comma N diethyl ethanamide is the correct IUPAC name of this compound. And then you left with the last one. So how I can name this last one? 1, 2, 3, 4, 5. Okay. Now the problem is that, what is the problem? This is your what? Acid halide. And this is your acid amide, and in the priority table acid halide is at the top position, but this acid amide is at the bottom position, bottom relative to this one. Okay, relative to this one. So the IUPAC name of your compound would not be amide this time, but it is your what? Acid halide, that means bromide. So you need to know whenever your carbonyl and your NH2 will present as a side chain, then how you will write. So please remember, earlier I made a mistake and then I went back to correct the problem in my priority table. Here you can see this CONH2, when it is present as a side chain, when it is present as the side chain, it is basically your carbamoyl. Basically your carbamoyl. That means this numbering is wrong. This numbering is wrong because principal functional group is this one. So you cannot start numbering from that end. You have to start numbering from this end. So you write 1, 2, 3, 4 and 5. So at 4 position you are having that substitution. There is no need to write 5. So that is 4 dash carbamoyl. Okay, and then you can see 4 carbons are there, that means but, and these 4 are connected with a single bond N and your oil halide. So this is the example where you are having the 2 different kinds of the functionality. One is acid halide and other one is the acid amide. But in the priority table, acid halide is at the top position relative to this acid amide. So the IUPAC name will be your according to the alkanoyl halide, but not to the alkanamide, and your amide part would be the prefix, and when your amide part is used as prefix, then its name is the carbamoyl, and that carbamoyl is present at the position number 4. So 4 carbamoyl butanoyl halide. Okay, so this completes the IUPAC nomenclature of carboxylic acid and acid derivatives. Okay, in the next class I'll continue with the aldehydes and the ketones, right? So if you have understood the things correctly, please like the lecture, okay, and subscribe my channel Tetrahedron Chemistry classes, and do share with your friends as well. Okay, so I'll meet you in the next lecture. That's it for today. Thank you. Thanks for watching.